These are the solutions for the study guide for Chapter 6, Section 3, and Chapter 6, Section 4, examples 1 and 2. So let's take a look at our first problem here. It says, use the graph to write a linear function in slope-intercept form that relates y to x. And so when it says relates y to x, it just means we're going to write it in this form, y equals mx plus b. This is the slope-intercept form. We're going to have y by itself and the x expression as the x term in an expression here. And then we're going to interpret the rate of change, and rate of change just means the slope. It's that m value right there. So we'll interpret that for the linear function. So let's take a look at our graph. When I look at the graph, always look at your y values, the intervals here, and the x intervals. And so it looks like it's going up by 1. It's going over by 1 as well. So my slope is 2 to 1. That's what we end up seeing here as we're going up. So it's 2 over 1. And so we'll write down that m equals 2 over 1, which just is 2. And then my y-intercept. Where does it cross the y-axis? Right here. That's the y-intercept. And so that's going to be negative 3. So I know the equation's y equals 2x minus 3. So that's part of it, but then we have to interpret that slope. And so what the slope means is, we'll say, the slope is 2, which means as y values increase by 2, x values increase by 1. That's what that ends up representing. So the next problem is pretty much the same problem. The difference is instead of having a graph, we've got a table. So use the table to write a linear function. Again, it says write a linear function in slope-intercept form. So that, again, is that y equals mx plus b. And then interpret the rate of change. And so we're going to find the slope by subtracting the y values. So it's difference of y's over difference of x's. So I take the 5 minus the 4, and then I'll do negative 2 take away 0. So it's going to be 1 over negative 2, just makes negative 1/2. And then the thing about this problem is they actually give us the y-intercept right here. So whenever you've got x equals 0, we've got the y-intercept. So if x equals 0, that means this is the y-intercept. And so the y-intercept is 4. And so that means that b equals 4. And so all I'm going to do is I'm going to rewrite it in this form. Y equals mx plus b, so it's going to be negative 1/2 x plus 4. And so then I have to interpret the slope. So we'll just say the slope, again, is that rate of change. The slope is negative 1 to 2, which means y values increase, actually we'll say decrease. Could say increase if we said that the x values decrease, but I'm going to go with y values decrease by 1 as x values increase by 2. So moving on to this next one, it's the same sort of one as this last one. However, now instead of just a table that had meaningless values, we actually have some meaning here. So it says the table at right shows the amount of gasoline G in gallons left in your tank after you've traveled m miles. And so it says write a linear function that relates the amount of gasoline. Now let's see how it says amount of gasoline to the distance traveled, just like here, y to x. So we're going to do the amount of gasoline to the amount of distance traveled. So md plus b. So instead of y and x, we're using g and d. Or actually, instead of d, they used m. So let me fix that real quick. So they used m in place of the distance. And so we got 2m, so that's a little confusing in this case here. But I'll go ahead and write it in there. So this is the slope m, and this is the miles m. And so that's the difference. So we're going to go ahead and find the slope of the line. So this is the slope here. And our slope is going to be, we'll take away the y value is 20 minus 19, so I subtracted those over 0 minus 20. So that leaves me with 1 over negative 20, and most people like to see the negative 1 on, or the number on top as a negative, so I'll write it that way. And then I'll find the y-intercept, and I have it right here. You see there is the y-intercept. So again, when the x term equals 0, you've got your y-intercept. And so I'm going to rewrite this as, instead of y though, I'm using g. So g equals, and then negative 1 over 20 m in place of x plus 20. So the number of gallons equals negative 1/20 times by the number of miles plus 20 gallons. And so now I have to interpret the slope. So the interpretation of the slope and the y-intercept. So the slope is negative 1 over 20, which means that, and the y value represents the negative 1. So it's going to be, which means the car consumes 1 gallon. So consumes means that's in place of the negative sign right there. Consumes 1 gallon every 20 miles. So 1 gallon it consumes. That's where the negative sign came from, positive 20. And that's why it makes more sense to have the negative sign with the 1 rather than the 20. Otherwise, we'd be gaining a gallon every negative 20 miles, and that's hard to understand. So then we have to interpret the y-intercept. The y-intercept equals 20, which means the car started with 20 gallons. And so that's what you have to remember with the y-intercept. Y-intercept, the B stands for beginning. That's why they use a B there. And if I'm beginning with something, you use words that are similar to that. So like started with or initial value is how you can describe the y-intercept. So those are two of the parts. And then the last part asks us how many miles or how many gallons are left after driving 120 miles. So g equals negative 1 over 20 times by 120 plus 20. And so if I go ahead and do this work, 20 goes into 120 6 times. So negative 6 plus 20 makes 14. So 14 gallons are left after 120 miles. So moving on to the next problem, it says Al earns $15 an hour and receives a $50 bonus. Well, $15 per hour, this is the rate of change. And so I know it's a rate because of that word per. So that's my rate right there. And bonus, this is a one-time deal. So this is the y-intercept. And that's our beginning value. So let's write down Al's equation. Y equals, and we're going to go 15x plus 50. And I'm saying y equals the amount of money, x equals hours. Now, Ed's earnings are on this chart, and it says $3.75. So 3 hours, $75. So we'll say Ed, his earnings are 75 over 3x. No initial amount because he starts at 0. So it's plus 0 there. So I'm going to reduce this. This makes 25. And so what that represents is his hourly wage. So who earns more? Well, Ed's wage is higher at $25 per hour compared to Al, who earns $15 per hour. And then it says after how many hours will they earn the same? Well, same means equals. And so whenever I see that word, I think of equals, and I'm just going to set their expressions equal to one another. So here is Ed's 25x equals Al's at 15x plus 50. So I'm going to take away, I'm going to subtract their rates of change, their their wages. And you see that Ed earns $10 more per hour. Well, let's divide that $10 per hour into $50 and find out how long it takes him to recoup that cost, or at least cover that. That's going to be 5 hours. It's going to take him to make it so they end up making the same amount. Now the next problem asks us, does the table represent a linear or nonlinear function? So for that, what we're going to do is compare the x values and y values. So what we need to see is, first of all, the x values need to be going up or down by a constant amount. And then we can compare the y values. So I see that these are going up by a constant amount. Now I look at the y values, and it looks like it's going down by 4, but then it's going up by 4. And then it ends up going up by something else. It goes up by 12. So you see how these are not constant. Not constant. Not constant. Not, we'll say not a constant rate of change. And that makes it nonlinear. So we would say nonlinear. Nonlinear because the y values do not change by a constant amount. So looking at this next one, we have to determine whether the graph is linear or nonlinear. And this linear means line. If you look at that word right there, cross off the AR, you've got the word line. So it needs to form a line. And this is not a line. This is a curve. So this is nonlinear. Nonlinear because the graph curves. And if it curves, that means that the slope changes. So we'll say the slope changes. And you have to have a constant rate of change. You have to have a constant slope in order for it to be a line. Well, let's take a look at our last few problems here. Here's a good substitution problem. I'm going to take that 1/2 x minus 5 and put it in for y in this equation. So I've got 4x plus 2, and then I put the 1/2 x minus 5. And all equals 0. So I double these two numbers and I get 4x plus x minus 10 equals 0. So I combine some like terms, makes 5x. Move that 10 over, and this all equals 10. So I divide by 5, x is 2. So once I get that, I can substitute back in and find out what y is going to be. And so I go ahead and multiply, take half of 2 makes 1, subtract that from 5, or subtract 1 minus 5 gives me -4. So my answer is 2 comma -4. And you can check your answer by substituting into the other equations. So 4 times by 2 plus 2 times by -4 should equal 0, and it does. 8 plus -8 does equal 0, so we get a true statement here. So this is true. So on the next one, they want us to plot these points, and then we want to rotate the figure 90 degrees about the origin. So let's start by plotting. So 1, 1, there's A, and then 3, 1 is B, here's A, and then C is over 3 up 4. And so here's our figure. Now we want to rotate it about the origin. And so when I rotate about the origin, I can actually turn the page. It's a little hard to do on this because you got to turn the computer screen around, but if I was to, notice that it goes clockwise. Clockwise means it's going to go into this next quadrant right here. So this axis right here is going to move down here to the y-axis. So that's part of the rule. The x-axis becomes the negative y, or becomes the y-axis. And it also changes signs, so we're going to put it there. And then the y-axis right here, the positive y-axis, goes to the x-axis, and so it's going to go here. So this is going to end up being the rule. And so when I rotate it, my a value is going to go right down here, and the b value, see this, it's going to be one space from this axis, which is now down here. So it's going to be one space from it, so it's going to be right here. So that's going to be b prime. This was A prime. And then C prime, notice how it is right in line with B. So it's going to be right over here, and that's about where it's right there is where it's going to end up being, C prime. And so we can go ahead and draw it out, and that's what we see. Now we have to also plot the figure and find the coordinates of the image. So the coordinates, and if you look at it, we'll put in A prime here. It's going to be 1, negative 1. B prime is going to end up being 1, negative 4. C prime is 4, negative 3. And just by looking at one of them, let's take a look at C. See how 3 went to the Y value and it changed sign, and 4 just goes to the X value. So looking at this one, it says the price of 2 pears and 6 apples. So let's say P equals the cost of a pear, and we'll say A equals the cost of an apple. And so we've got 2 pears plus 6 apples is $14. Price of 3 pears and 9 apples is equal to $21. And so now what I'm going to do to find out what the value is, I'm going to go ahead and multiply this equation by, let's go with negative 3, and this one by, let's go with positive 2, just to cancel out the p's. So when I do that, I end up getting negative 6p minus 18a equals negative 42. And when I do this one, I get a positive 6p, so those are going to cancel out now, but I get a positive 18a and a positive 42. And so when I go ahead and add these two equations together, everything cancels, and I get 0 equals 0. And so what this means is that we had the same exact line. So I cannot determine what the answer is. So you cannot, we'll say costs can't be determined. Can't be determined because the equations are the same. And we would need 2 different equations to be able to come up with that answer if we're going to solve a system. If you have 2 unknowns, you must have 2 equations, and we only have 1 equation here because both of these are the same. So cost cannot be determined because the equations are the same, which means there would be infinitely many solutions. So those are the answers to the study guide. Good luck on the test.